Stay here.
Good morning, everyone. Welcome to the second day of our Feed and Gut Health Webinar Week, organized by Informa Markets. My name is June. I am the Senior Sales Executive from our Livestock Series exhibition. Today, our first session, we have special speaker from USA, Dr. J.T. Pope. He received a PhD in Animal and Poultry Science and Nutrition from North Carolina State University. And right now, he is currently working for House of Rainford as a nutritionist. He will be presenting on the topic feed manufacturing, impacts on broiler nutrition, pelleting, and grinding. So if you have any question, please feel free to ask in our Q&A box, and we will try to answer all the questions after his presentation. So now, please welcome Dr. J.T. Pope.
All right. Good morning, everyone. It's quite late here in the United States right now, but it is a real pleasure to be with you guys today. I'd rather be in Asia giving this talk to visit with everybody in person, but I don't think that's an option right now. But through the talk, I hope that the information that we're able to provide is practical and useful, and there should also be some time at the end for us to discuss what I spoke about. So feel free to send us some questions as we go through. So just a little background, I did go to North Carolina State University. I worked with Dr. John Brake and Dr. Adam Fahrenholtz there, and got my degrees in nutrition and animal and poultry science. And really our lab focused on feed manufacturing and its impact on broiler nutrition. That was my primary focus, as well as a few lab mates. But we were kind of a broad lab that focused on management and gut health and food safety and breeders and antibiotic-free production. So we kind of did anything relating to poultry. And after graduation, I started working as a nutritionist with a broiler integrator in the United States. We're House of Rayford, and we're about the 10th largest broiler integrator over here in the States. So before we get into kind of the more technical details, I'd like to take a minute to talk about kind of my feeding philosophy, which has been influenced by professors and my current boss and other people and other mentors. I think it's very clear that we can overcomplicate things at times, or we can keep them very simple. And from kind of my general experience is that we can only focus on what we can control and monitor. You know, there's lots of things out there that are new, and we should pay attention to them and what is coming next, but we should focus on being good at what is actually within our control. And I think we always have to remember that the animal and the bird has an origin regardless of our technical advancements. So we can't change the physiology of that animal. We can't change the anatomy of that animal, but we can try to influence it and their metabolism and physiology as best we know how. And recently at the Poultry Science Association meeting, Peter Crystal out of Australia made a very interesting analogy here that with nutrition, we often measure with a micrometer. We can get very specific with what it is that we measure, and then we mark our target with chalk. So we get a wide line, and then we try to cut it with an axe. So we went from a micrometer to cutting something with an axe, and that does certainly seem to be the way that nutrition falls out. And one last slide before we get started on the more technical details. This is a nice slide from Dr. Adam Fahrenholtz at North Carolina State University. And here on the x-axis, you see that we're increasing the level or the extent of processing our feed. And at some point, we get really good technical quality, but our nutritional feed quality starts to decline. And that's where we wonder where our current situation is and how are we going to blend our technical quality and nutritional quality to maximize our feeding strategies. So starting off with a quick outline in our grinding, we will start to look at how and why we manipulate our grinding, the physical consequences of that on our feed, physical feed quality, as well as our gastrointestinal tract. And then we'll look at the nutritional consequences and talk about digestibility and how that may impact litter and our performance. So starting off with how and why we grind. We primarily grind raw materials to increase the surface area available for gastric enzymes to hydrolyze nutrients. And of course, that is the classical reason. If there is more surface area there, we should be able to more efficiently extract nutrients from those feeds. From a feed manufacturing standpoint, it also helps us mix the feeds and make a more homogeneous finished feed and decrease segregation. And of course, this is very important for us if we are feeding young poultry where our intake is measured in a few grams a day for the first couple of days. And grinding raw materials also facilitates the pelleting process. So pelleting and making a pellet would not be possible if we did not actually grind most of our raw materials first. So the grinding equipment that we typically have available to us are hammer mills and roller mills. And hammer mills are very much a grind by impact machine where we use high speed to grind our raw materials, and it's really good at giving us a fine grind. It's very efficient at giving us a fine grind that is useful for pelleted diets. And it is a bit cheaper to buy a hammer mill, and it is also much easier to maintain a hammer mill. Another piece of equipment that is available is a roller mill, and it is very much a grind by shear machine. So it does a better job at giving us coarse particles. And this would be really nice for manufacturing mash feeds that may go to breeders. But they are very expensive and very difficult to maintain. So we rarely see them in the United States in our broiler operations. So just to give you a quick update on where we're at in the United States with our grinding equipment, we are pretty much limited to hammer mills in the integrated broiler world. So really, we have to rely on variable frequency drives to change how fast our hammers rotate or rotors rotate. Our rotor diameter, just how big it is. Obviously, if it gets bigger, we're typically spinning it faster. And then our screen size is to control our particle size. So that's really the only thing,
in general, our tendency has been to overgrind our feeds, and our producers in the United States are starting to move towards a coarser grain. And we have done this because it helps us reduce manufacturing costs and improves our broiler outcomes. And that's what we will discuss going forward. So starting off with the physical consequences of grinding, here we're going to talk about particle size and physical feed quality. And I'm going to give us a pointer here. So we're going to talk about particle size and physical feed quality. And on the x-axis here, we have 3 particle sizes, and our response is pellet durability index. And we see that as with these much larger corn particle size at 850 microns versus around 400 microns, there's no difference in our pellet durability index. So it does seem that we can have a coarse corn in our diets without really impacting our physical feed quality. We also know that particle size will affect our gizzards. And on the x-axis, we have 3 levels of coarse corn from 0 to 50%, with the response being our relative gizzard weights. And we see very clearly that as we increase the amount of coarse corn in our diets, we get an increase in our gizzard weights. So that coarse grain stimulates the gizzard and exercises that muscle. And what that eventually looks like inside our broiler is apparent in muscle tone. So this is a very nice gizzard where we have clear separation between the proventriculus and the gizzard. Whereas in this case, we may have some proventriculitis from feeding fine ground diets, and we end up with a pass-through organ that simply does not work and has no tone. So our goal is to end up with a gizzard that has tone to it, that works to control the flow of feed and digesta through the gastrointestinal tract. So for a grinding physical summary, particle size influence on pellet durability is minimal. So we don't have to grind our diets to 300 or 400 microns as it may have been popular to do for many people in the swine industry in years past, at least in the United States. And we need to monitor our pellet quality, but if we're bagging feed and we're going to be pelleting return fines like we may do in Asia, we certainly don't have as much to worry about. And larger particles in the feed leads to a larger gizzards in the broiler. And that enhances the gizzard tone and improves the reverse peristalsis of the gut. So that allows feed that is in the lower gastrointestinal tract to make its way back into more anterior portions to improve our digestion. So now let's move into the nutritional consequences of grinding our feeds. And I'm going to focus on one trial that does a very nice job summarizing the impact of coarse grain on the nutrition in our broilers. So for this trial, there were 2 corn particle sizes, 300 and around 1350 microns. And the 3 treatments were either all fine corn at 300 microns or 25% of the diet as 1300 microns, with the remaining being 300 microns, or 50% of the diet at 1300 microns. And this trial was a 42-day growth study. So starting off with the live performance, on the x-axis, you'll see our 3 levels of coarse corn. And our response here is body weight in the green line and feed conversion in the yellow line. And what they saw is that as their coarse corn inclusion increased, there was an increase in body weight and a decrease in feed conversion. So it does seem that having coarse grain in the diet is beneficial for our performance. But we need to understand why our live performance improved. And the study did a nice job looking at retention of feed within the gastrointestinal tract, as well as diet digestibility. So again, here we're going to look at particle size and the impact on gastrointestinal tract retention time. And what they saw was that as their coarse corn inclusion increased, their gastrointestinal tract retention time increased by about an hour. So that feed spent an hour longer in the gastrointestinal tract than it did when feeding fine corn. And what that manifested to was improved energy digestibility. So again, 0, 25, and 50% coarse corn. And we see that with our diets feeding coarse grain, we had an improvement in our energy digestibility and also in our nitrogen digestibility, which of course is our amino acids. So we have better energy digestibility and better protein digestibility when feeding coarse grain. So for a grinding nutrition summary, when adding coarse corn to the diets, we see that we can improve our live performance parameters. And this is through improved energy and nitrogen digestibility, and also through reduced feed transit rate. And the improved digestibility is likely due to increased exposure to enzymes and nutrient transporters from spending more time in the gastrointestinal tract. So we're getting less feed passage and likely better litter quality as well. So for some practical recommendations around coarse grain feeding, we do need to be careful not to overstimulate the gizzard in our starter diets. And that is something that we have seen in practice, where if we start feeding coarse grain immediately, sometimes it will have a negative impact on growth if we overstimulate the gizzard early on. So in practice, it may be best to wait until the second feed phase to introduce coarse particles if our feed mills will allow it. And I know that not all feed mills have the ability to grind to 2 different sizes or to use 2 different corn programs, but if possible, we should wait until the second diet to introduce coarse particles. For us, corn particle size of around 800 to 850 microns has been beneficial for us in a research setting, and certainly commercially, I've seen people push this even further. However, there may be some duration-related benefits. And in the United States, we do grow large broilers. We have some groups that are growing broilers over 4.5 kilos. So the bigger the bird is, the more beneficial often coarse grain feeding becomes. So just a couple practical recommendations around coarse grain feeding. So now we're going to move on to pelleting. And again, we'll talk about how and why we manipulate our pelleting and pellet quality, the physical consequences of those actions, and the nutritional consequences as it relates to digestibility, enzyme thermostability, and performance.
Dr. JT.
How and why do we pellet? Well, of course, we use a pellet mill, and the reasons we use them are to make pellets to reduce feed waste improve our material handling so that we can get more material, for us in trucks in the United States where we're delivering bulk feeds, and also increased densities. And this helps us also, it helps our animal itself. If they can,
Dr. JT, I'm sorry.
Gut feel, they should be able to eat more nutrients.
Dr. JT, I'm sorry for.
It also improves our palatability and decreases the feeding duration. So if we have a broiler house with feeder pans in it and we have good pellet quality, that good pellet quality allows broilers to feed more efficiently and open up feed space for other broilers in the house. And then in some areas, of course, we look towards pelleting as a feed hygiene method. And then there should always be a monetary return for pelleting our feeders. So looking into our current broiler situation in the United States, our broiler industry is primarily integrated. So we have bulk delivery of feeds and we have contract growers for the most part. So there's not a huge focus on pellet quality. No one is opening a bag of feed and to feed broilers in the United States for the most part. So pellet quality is not as much of an issue. We're often maximizing our throughput, and that's to maximize our equipment. And this typically pushes us towards hotter conditioning temperatures and post-coating fat to preserve our pellet quality. And that's the only way, because the throughput is so fast that we can actually maintain any type of pellet quality.
Dr. JT, I'm sorry. Dr. JT, can you hear me? Hello? Dr. JT, sorry for interrupt, but we cannot hear you properly. Maybe there is some internet issue from your side.
We also do not screen any of our pellets. One second, guys. It sounds like we may be having some technical difficulties here. I will get back to this in just a minute.
Thank you. I'm sorry for the technical problem. We will fixing it now. So please be patient and stay with us. We will come back soon. But anyway, we will also have the 2 sessions for today, our feed and gut health webinar weeks, which we will presenting on the implications of low doses of mycotoxins for animals production and how to correctly manage them. And the last session for today will be black soldier fly larvae as animal feed in Asia, inside with AFFIA, which is the Asian Food and Feed Insect Association. So please stay tuned with us. We'll be in 1 p.m. and the last session will be at 3 p.m. Thailand time. I think okay. Dr. JT, did you okay now? Okay, so please wait a bit more. So just to remind you that we also have our livestock exhibitions for next year, our livestock Malaysia and our livestock Philippines and our VIETSTOCK. We have been postponed because of the COVID situation pandemic. So we would like to invite you all to attend our exhibition next year as well. So Dr. JT.
Buddy,
Hello, Dr. JT.
give me 1 second, buddy. I'm gonna start presenting again and see if it works.
Okay, sure.
Hey, June, can you hear me?
Yes, yes, we can hear you, but we cannot see you right now.
Okay. Let me start the video. It's saying that it's my computer's telling me it's unable to detect a camera.
Mm.
So should I just go back into the? Yeah, it's not finding a camera. Should I just go back into the presentation?
Yes, please. Yes, you can continue from the presentation. Yes.
Okay. All right. Sorry about the technical difficulties. It always seems like there's something. Anyways, I'll try to get through this so we have a little bit of time at the end. But this is a good piece of data from a group called McKinney and Teeter that shows us the importance of pellet quality. And you see on the x-axis that as our pellet quality declines, there's a decrease in body weight gain and an increase in feed conversion. So we need to try to maintain good pellet quality to maximize the genetic potential of our broilers. And this is a nice pie chart showing us the different ways that we can manipulate physical feed quality. And I know we spoke about particle size a little bit earlier. It's of my opinion that it is not that large of a piece of the pie, but I think our focus should be on the pellet mill die, feed formulation, and conditioning, and the way we condition our feed. So starting off with the physical consequences of pelleting. On the x-axis here, we have our conditioning temperature, and our response is our physical feed quality. And what we see is that as our conditioning temperature increases, there is an increase in our PDIs. So this is one way that we get good pellet durability is through increasing our conditioning temperature. On the formulation side of things, we often manipulate the amount of fat in our diets. And this is data from SATID, which many of you may know, SATID Adawang. And he showed us that as our mixer added fat levels increase, there is a decrease in our pellet durability index. So typically we try to withhold fat from the mixer to improve our physical feed quality. Something else that has a large impact on physical feed quality is our throughput through our pellet mills. And what we see is that as our pellet mill throughput increases, or as the feed spends less time within the pellet mill die, there is a reduction in our physical feed quality. So in summary, for our physical feed quality, we have a tendency to increase our conditioning temperature, reduce the level of fat in our diets, or use post-pellet liquid application systems where we push all of the fat downstream. And in practice, we often use the thickest dye that we can use without drastically impacting our throughput. So what this likely does, though, is it increases the frictional heat and pressure within the pellet mill die, and all of those factors may actually negatively impact our thermolabile nutrients and ingredients. So now moving into the nutritional consequences of pelleting. So as we talked about earlier, we have a tendency to increase our conditioning temperatures to maintain physical feed quality. And here we're looking at the digestibility of methionine, isoleucine, and proline based on 3 different pelleting temperatures. And what we saw is that as the pelleting temperatures increased, there was a reduction in our amino acid digestibility. So high pelleting temperatures leads to less digestible feed. And amino acids are not the only nutrients that are impacted by high temperatures while we pellet. Here we're looking at 4 conditioning temperatures and phytase recoveries. And what we see is that as our conditioning temperature increased, especially above 80 degrees, there was a reduction in our enzyme recoveries, or in our phytase recoveries. So we know that we can denature enzymes and amino acids through high temperatures. But we set out to answer the question of where exactly it was in the pelleting process that these nutrients or ingredients may be denatured. So we conducted a trial where we pelleted diets at 3 different temperatures and looked at phytase recoveries either coming out of the conditioner, so before we made the pellet, just after it had been treated with steam in the green bars, or after the pellet mill die, once the feed had been pressed in the orange bars. And what we saw is that as our conditioning temperature increased, there was really a minimal amount of denaturation in the conditioner. But after that feed was exposed to the heat and pressure and friction within the dye, in our orange bars, that is where we actually denatured all of our enzyme. So this told us that the conditioner may not be our only issue. When it comes to nutritional feed quality after pelleting, what occurs within the dye may also be a large impact. And we also looked at throughput and how this may impact our enzyme recoveries. So again, we have 4 different throughputs on the x-axis, and our response is our phytase recovery. And the green bars are at 75 degrees and the orange bars at 86 degrees. And what we saw is that at 75 degrees, changing our throughput doesn't really influence our recoveries, and that we can pellet really slow and still get a good recovery at 75 degrees. But when we went up to 86 degrees, we saw that there was a large amount of denaturation when we pelleted real slow, because the feed spent too much time within the dye. But as we increased our throughput and the feed spent less time within the dye, we improved our recoveries. Something else of interest that we saw is that we can correlate many of the parameters we monitor and measure within our feed mills with nutritional feed quality. So on the x-axis, we have our pellet durability index, and our response here is phytase recovery at 86 degrees. And what we saw was a very clear decrease in phytase recoveries as our pellet durability index increased. So we can monitor for physical feed quality, and it may relate directly back to our nutritional feed quality. Something else we looked at was the amount of frictional heat within the die. And remember, we showed that if the feed spent more time within the die, we were more likely to denature some of our enzymes and some of our thermolabile nutrients. So here we are looking at the amount of frictional heat within the die on the x-axis. And what we saw that if we hold all of the other factors constant, such as our conditioning temperature, and we have an increase in our frictional heat in the die, we get a reduction in the amount of phytase that we recover from our diets. And this didn't just show up in an in vitro test where we're just looking at enzyme recoveries. This translated all the way out to our broilers when we looked at 28-day phosphorus digestibility. So you'll see those two slides mirror each other, where as our frictional heat increased and we denatured more of our phytase, we got a reduction in our phosphorus digestibility. So this doesn't just happen in a test tube. This is something that is occurring in our broiler houses. And we can measure something physical in our feed mills that has a direct correlation with the nutritional that our broilers receive. So for a pelleting nutritional summary, it is possible for us to overprocess feed for hygienic or physical reasons. And this may lead to poor digestibility of amino acids and enzyme-related nutrients. However, we may be able to correlate some of these physical feed quality parameters with nutritional feed quality through frictional heat and pellet durabilities. And for practical recommendations, I believe we should try to meet the hygiene requirements with the least amount of steam. And I know for export markets, there are sometimes more stringent standards in other places than we may have in the United States. But I really don't like to see people trying to pellet over 88 degrees Celsius. We should also test to ensure that meeting our physical feed quality demands is not destroying our nutrients. So we should test this against enzyme recoveries or reactive lysine or using a broiler digestibility trial. Make sure that our push for physical feed quality doesn't outweigh its benefit in nutrient destruction. And if need be, educate customers about the nutritional benefits of less processing. So we have had a tendency in the past to overprocess our feeds. Maybe it's time that we use coarser grain and don't worry as much about pellet durability so that we can maximize the nutritional components of our diets. Thank you all for listening. And if we have any time, I hope we can have a good discussion here at the end.
Thank you, Dr. JT. Right now we come to the Q&A session, but anyway, I'm sorry everyone for the technical problem. We still cannot see Dr. JT both face. We would love to see you anyway. Doctor, will you try to open the camera and answer the question?
Yeah, my program still isn't letting me open my camera, and I apologize for that. I have no idea why my camera always works, but when we get on a webinar with people, it doesn't want to back. And
Yeah.
I do apologize for that. But it doesn't look like my video is going to start.
Yeah, I'm sorry everyone for that too. So in that case, let me start with the first question. Okay. So the question from the audience, they asked that any recommended equipment provider for pelletizing that most efficient.
So the question was if there's any particular equipment provider. Is that right?
Yes, yes.
Well, you know, I don't endorse any one particular company per se. Just generally speaking, in the United States, the majority of our broiler producers are using CPM equipment, California Pellet Mill. And that is by far the vast majority of the pelleting equipment you will find in our feed mills in the United States.
Okay, so for the next question, what is the strategy to ensure the availability of feed ingredients in this pandemic condition?
So that is a very good question. When the pandemic first started for us, we struggled on several ingredients and getting them into our meals, especially our meat and bone meals and animal byproducts. That was a major challenge when all of the processing plants were taking a break. And then even more recently, we bring in lots of our raw materials on rail lines. And right now, the rail lines are having problems with labor and getting raw materials to us. As far as sourcing them and trying to get them in, I don't have a clear strategy just during these times, other than work with your suppliers and hold people to any contracts that purchased.
Right, all right, thank you. And the next question will be the ideal temperature for pelleting and how long it has to be inside the extruder.
Yeah, so we don't extrude any broiler feeds in the United States. They're all just conditioned and pelleted. And what we typically like to see is that under 190 degrees, and our typical retention times in the conditioners are about 30 seconds. Some people are pushing through the conditioners much faster than that, but about 30 seconds, no hotter than 190 degrees. And again, we're not held to the same type of pellet quality or pellet durability standards that we may see in Asia, where there's more bagged feed products, but that's where we like to keep it so that we can still maintain nutritional feed quality.
Okay, we still have a bit more time for 5 minutes, so then I'm just I'm gonna keep asking. So then the next question will be like, what is the form of feed control to maintain feed safety in manufacturing?
Of course, there are several ways you can control feed hygiene, and of course, the one we discussed here today was through our conditioning temperatures. That's probably one of the most popular ones. There are some manufacturers of a piece of equipment called a hygienizer, where the feed is essentially conditioned and then pushed into an insulated shell for about 2 minutes, so that you don't only get a temperature effect, but also a time effect. Those have become popular. And other than that, folks may use formaldehyde-based products or other feed hygiene products, but typically don't see a lot of that used in the United States unless it's for our primary breeders, where they have to keep them clean of salmonella.
Okay, all right. The next question will be, what is the recommended length and pellet diameter for broilers feed?
So we often don't have the luxury of controlling the length of the pellet. Our pellet quality is not typically good enough, and our pellet mills typically don't have knives on them to cut them to different lengths. But the vast majority of us are using a 4.4 to 4.5 millimeter diameter pellet. And we have done some studies comparing 4.4 millimeter pellets to 3.5 millimeter pellets. And when we're growing a large bird, as we are in the United States, out to 60 days or 50 something days, the larger diameter pellet was more beneficial for us. But I think if you're in a smaller bird market, that 3.5 millimeter pellet may be just as effective.
All right, I see. Okay, so now come to the live question from Mr. Rio Shai. If I'm sorry if I spelled your name wrong. He is asking is like, what is the optimum particle size of corn for enzyme working in maximum rate?
So I haven't seen a whole lot of work that has been done on this yet, and I think that is a very interesting point that we should learn more about, is how exactly it is that coarse grain in the foregut and the action of the gizzard helps mix the enzyme and make it more effective. I don't know of any publication specifically right now, but that is certainly something that I hope we can learn more about in the future. But for us, you know, like I said, we found 850 microns to be very beneficial for us. In the United States, I would say typically we're seeing slightly below that for most broiler operations, but there are certainly people out there feeding coarser than 850 microns.
Okay, now come to the last question. If we are going to use corn or barley, what is your recommendation on the target particle size of these grains?
So as I said in the presentation, around 850 microns has been very beneficial for us in the past. That is for, again, a bird that may be larger than what is it throughout most of the Asian markets. So that's the only place I would be cautious. But when we're growing a 4 kilo broiler, 850 microns has been very beneficial for us.
All right, okay, thank you so much, Dr. JT Pope. For the rest of the question that been asking in our Q&A box and our chat box, we will pass through Dr. JT Pope to answer and get back to you by email later on. So thank you today, Dr. JT, and please stay tuned with us for the last two sessions for today. 1 p.m. for implication of low doses of mycotoxin for animal production and how to correctly manage them by Mr. Michele Mucho, Regional Product Manager, Mycotoxin Risk Management from Biomin. And the last session will be at 3 p.m. For black social fly larvae as animal feed in Asia with inside with Asian Food and Feed Insect Association. It will be the panelist, the panel discussion. So, and I'm so sorry again for all the technical issue problem. The recording video will be sent to the attendee as well. And thank you for joining us today. And thank you, Dr. JT. Thank you so much. สวัสดีค่ะ
Thank you, everyone.